This live SLU show is brought to you by the support of SLU members and the following sponsors. Visit SLU.com to become a member today.
Hi, and welcome to our latest live SLU show. I'm Eric Edelman, broadcasting to you live from Smoky Hollow Studios in SLU HQ in Washington Depot, Connecticut. And today we're going to be traveling across the ocean and going to the Canary Islands, 9,000 feet above sea level. And we're going to be checking out a beautiful, beautiful conjunction of the planets of Venus and Jupiter. And it's great to see this perfectly clear sky in the Canary Islands, and it's summer here in the Canary Islands, where about 95% of the days it is sunny. It's why we have one of our observatories over there and just one of the greatest sights to observe in the world, and it's going to be great to be bringing you some beautiful live imagery that's going to be coming in just now of this exciting conjunction. And with me today to walk you through all of what's going on here, we have SLU astronomer Bob Berman, who's going to be giving us the ins and outs of conjunctions, and this conjunction in particular. So welcome to the show, Bob, and thank you very much for joining me tonight.
It's absolutely a pleasure. You're in a good mood, aren't you, Eric?
Oh, yeah,
I think the
I'm
conjunction is
always in a
bringing out
good
the
mood.
best in us.
This is a fun, really fun sort of event to celebrate, in particular, just because there's so much going on. And we actually have been doing some intriguing things with the SLU scopes tonight to make sure that we're going to be getting that live imagery to you, where we're actually this group of stars, or this group of planets, Venus and Jupiter, are actually so low in the sky and the horizon of the Canary Islands right now that we can't actually show them with our T2, our planetary imaging scope. And so what we're doing is we're using our higher powered T1 scope to image these objects, and our observatory engineer, Paul Cox, is having to customize this imagery, the visualizations of this imagery to make sure that we're getting it. And it's been quite an adventure. We're using what's called an H alpha filter with only 2-second exposures. Like, Can you sort of contextualize that for us, Bob? Like, what does that mean in terms of imaging something?
Oh, that's very cool. And it's very unusual. And he's the wizard. He's the one who's behind the scenes. He's doing all these things that nobody's even watching. And that's why he allows the telescope to override its normal limits. How low it can see. He's the guy. And we've been waiting for this conjunction for months. Venus has been brilliant ever since it emerged from behind the sun's glare and has been getting more and more prominent, still brightening up. It's just about at its brightest now. And at the same time, there is Jupiter moving slowly, as it always does, because it takes 11.86 years, almost 12 years to go around the sun. So it's been sitting there in the constellation of Cancer, the crab, not too far from Leo. And Venus moving fast because it moves at 22 miles per second, 40 times faster than a high velocity rifle bullet, heading toward Jupiter night after night after night. And this is the series of days. Last night, tonight, this is when they're closest. And we got them.
We do indeed. And really, without any further ado, here is a live imagery coming in from T1 just to show you here. This what we see as this bright blooming object. This is Venus. And just a little bit above the screen, just a little out of the screen, is Jupiter. And what we're going to be working on right now throughout this show is to try and get those in the same frame. It's going to be a close call, and we're going to try our best to do it. But we're going to see these planets throughout the night as we struggle to see them both together. And that is Venus.
Yes. And you don't have to struggle. I'm talking to our members who are watching this show. If you're in a place that has clear skies, maybe you are, maybe you're not. But if you are, and it's around sunset, wait till about half an hour or 45 minutes after sunset. Look in the direction of the setting sun, where the sun did set, and you can't miss it. There they are, the two brightest objects in the night sky, other than the moon. And brightest one is Venus, and the other one is Jupiter. So you don't need star maps, or you don't need your personal astronomer around. We're here to celebrate it and to look at the lore and legend and mythology and science behind this, because conjunctions have always been celebrated throughout history. The Mayans would throw their least favorite in-laws from pyramids down on the Yucatan Peninsula and other parts of what are now Guatemala and southern Mexico. And other cultures did too, to celebrate bright conjunctions. This is the brightest of the year. This is really the best. And so when we look at it, we take different views, close-up views, and we had it just before we went on the show, them in the same field of view. So I know, although it's tricky, we're going to do it again. But again, to our listeners, head outside. If it's clear and if it's the right time, there'll only be about a half an hour window where it's optimal. That is, when they haven't gotten too low, and yet the sky has gotten dark enough behind it to show it optimally. And that happens about 40 or 45 minutes after sunset. For most parts of the United States, that's around 9:15-ish or so, or 9:30, depending upon how far you are from your local time zone line. And, look for it yourself. This is a naked eye object. It's great to use the SLU instruments, but this is one case where you don't really need anything. It's just drink it in.
Absolutely. And yeah, so you look out at the night sky, and as we see the all sky over the Canary Islands, the sun is not becoming such a hassle for us, because it's different time zones over there than the United States. And so as we're thinking of visualizing this in the night sky, what about visualizing this in the context of our solar system? Like, what does it mean for two objects to have a conjunction?
Well, it means that they're in the same spot in the sky. And this is an excellent diagram that shows it. You can see where Earth is, third planet from the sun. We're looking towards Venus. And look, right behind Venus in that same line is Jupiter. Although they look side by side in the sky, Venus is actually between us and the sun. And Jupiter is 5 times farther away from us than the sun. So it's way off in the distance. And that also bespeaks its orbital motion, because as planets go around the sun, they all go in the same direction, counterclockwise, if you're north of the solar system. And they all move at a faster speed if they're closer to the sun, slower if they're farther away. They have to to fight the sun's gravity. If Mercury didn't move as quickly as it does, it would be pulled in by the sun's gravity. So because of that, Venus moves at 22 miles per second. 35 kilometers per second. Now, as I said, it's 40 times faster than a high velocity rifle bullet. But way off in the distance, Jupiter is so far from the sun, its speed is only 13 kilometers per second, or 8 miles per second. So 8 miles per second for Jupiter, 22 miles per second for Venus. So Venus is moving much faster. Plus, look at it. It's so close to us. So when an object is closer, it looks like it's moving faster, even if it wasn't. For example, the cars on your street change their angular position much faster than a jetliner in the sky in the distance. Even though we know that the airplane is moving much faster than the car, it doesn't look that way. The car, you have to move your head to watch the car move. You don't have to move your head actively to change positions to see the plane from one second to the other. So same thing here. Venus is the car that's nearby. Jupiter is the more distant object, except in this case, Venus actually is traveling at a faster rate. Plus, it's nearby. So because of the combination of those two, we can use Jupiter as sort of a stationary reference point if we want to do some nice naked eye astronomy and watch it from night to night as Venus changes its position. Last night it was below Jupiter. Now it's to the lower left. Tomorrow night it's going to be straight to the left. And overnight, literally, we can see it changing because it's so darn close to us and moving so quickly.
And we're seeing right now, actually, this is an image that sort of speaks toward the topic that we're going for, which is the difference in speeds between these two objects. We see one of them really, Venus, very much moving a lot quicker than Jupiter, as our wonderful feed partner, Gerard Lazarus in Australia, has been imaging these objects over the course of a night, of multiple nights. And so we see that progression, we see that difference.
Very cool. And this also shows that we really do live on a curved planet because here Venus is moving from directly below Jupiter and then passing it and going just about vertically up, where the rest of us live here in the United States. Most of our members are in Europe, America, Canada. And for we who are in the north temperate areas, it's really a right to left. It's lower right to upper left motion. So it's a different direction. In fact, if you want to use this, what our Australian feed partner has done, just cock your head like a puppy and just turn it to the right. And then you'll get the view that you'll see out your window if you live in the United States, Canada, or Europe. So the motion of Venus is quite different. Of course, there is no difference in space. The difference is simply whether you're upside down, as the Australians unfortunately are. They have to, they have that blood rushing to their heads at all times. They living on the bottom side of the planet. It's hard for them to get used to it, and but we don't. We're right side up. Hey, look at this! I can see that. Paul has succeeded in capturing these two planets in the same field of view.
This is our conjunction, ladies and gentlemen. Enjoy. This is Venus and Jupiter in the same field of view. And so we're seeing what looks like a little trail of dots underneath Jupiter on the left there. And so what is that?
Yeah, those are 3 of its 4 Galilean satellites, with Ganymede, the brightest of them, on the bottom, and Europa and Io just above them. And Paul has very wisely set the exposure to capture Jupiter, because Jupiter has the interesting stuff, the moons, whereas Venus on the right is much brighter. To put real numbers on it, Jupiter is about magnitude -2.5, and Venus is almost magnitude -5 currently. So we're talking about more than 2.5 times, 2.5 magnitudes, which corresponds to 10-fold brightness difference. So Venus appears 10 times brighter, and you have to compensate for that when it comes to the exposure. If you're going to correctly expose one of these, you're going to underexpose or overexpose the other. So what we've done is correctly expose Jupiter for its moons so that they don't just flare out incomprehensibly, and that means Venus is overexposed. In actuality, Venus looks like a gibbous moon right now.
Mm.
It's between half and full in its phase, but there's no trace of that because of this flaring. In actuality, they both, in angular size, are about the same. So if you use a backyard telescope or command the SLU telescopes to look at both of them, you and we or we didn't expose it excessively, you would see Venus on the right having a apparent disk, a body of about the same visual size, apparent size as Jupiter. In reality, Venus is only a little more than 7,000 miles in diameter, whereas Jupiter is 88,600 miles in diameter. So, you're talking about a 13 to 1 diameter difference between the two worlds. Jupiter is much bigger, but Venus is much closer, and it's got those shiny clouds on it. Venus's clouds form an overcast that are the most reflective objects in the entire solar system. They reflect about 90% of the sunlight that hits it, which pretty much matches, it's somewhere between a mirror and fresh snow. So dazzling. And then on top of that, the sun itself is brighter hitting Venus because Venus is so much closer to the sun than is Jupiter. Think about it. The sun way out there at Jupiter's distance is about 25 times less intense than the sunlight that we get here on Earth, whereas the Venus sun is brighter, more intense than the sunlight we get. So you put that together. More intense sunlight is hitting Venus. It's closer. It's more reflective. And so no wonder it appears 10 times brighter than Jupiter. Jupiter's clouds are no slouches. They reflect about 50% of the sunlight that hits them. In other words, they have an albedo of 50. That's how we talk about it. But Venus is almost twice as reflective. So there they are. Two brightest objects in the night sky after the moon coming together. And no wonder civilizations always made a big fuss out of them. Of course, they had superstitions about them. Venus was, the goddess of love, and it's appropriate that we make the brightest thing in the sky, the brightest star-like object, represent love, isn't it? I mean, that's a lovely thing for anybody in love who's ever been in love. That's nice that brilliance equals, those kind of positive emotions. Jupiter was regarded pretty nicely also as being involved with good humor. And we have the expression jovial that comes from that, as opposed to poor Saturn beyond it, where because of its sluggish motion, we would say that anyone who is Saturn like was Saturnine, depressing, sad, sluggish, lethargic, can hardly move. That's because Saturn has a slow orbital speed. So we thought it had something to do with depression and heaviness and sluggishness. So all of the planets had all of this mythology and lore attached to them too. So on top of the science and on top of the loveliness, we have these ancient traditions. Mars, because of its redness, was thought to have something to do with blood and fire. And even today, we speak of martial arts or somebody facing a court martial, meaning something to do with the military and war. So those legacies are still with us.
And it's really it's so great that you brought up these sort of personifications that come with these planets, because it's something that we love to celebrate here on SLU as well, as we're going to be celebrating another way to relate to the night sky personally. Just coming up next week on the 7th of July, we're going to be celebrating Tanabata and the journey of two star-crossed lovers, the stars represented by the lovers represented by Vega and Altair, as they come across the night sky and meet together on this one special day. So look forward to that when it comes up. But for now, we're actually going to be heading off to a talk between Bob Berman and a great friend of SLU, film director and producer Duncan Kopp, who is well known for his work on In the Shadow of the Moon. And so I'm really happy to introduce him and hear what you guys have to say. I think that's going to be a great conversation as we get more and more into conjunctions and what they mean to people and how we see them.
Okay, hey, hi Duncan, good to see you. How are things in jolly old England?
How are you?
I'm good. I'm really good. I know it's after sunset there for you, I would think. You're around the curve of the Earth. Here, we're looking forward to sunset here in the mountains in the eastern part of the United States and enjoying this conjunction. Were you able to see it tonight or was it cloudy?
I saw it yesterday, and it was amazing. I managed just to glimpse it through the clouds. We're having a bit of a heat wave in London at the moment in the UK. It was about 32 degrees today, which is incredibly hot for where we are. But there was a little break in the clouds yesterday, and I managed to see it. And
Excellent.
it's cleared up now, and I'm sure if I went outside, I'd probably be able to see it. And I've just noticed out of my study that there's a massive full moon that's just risen as well. So it's really beautiful out there.
Excellent. And for our members, I want to say again that Duncan Kopp is the celebrated filmmaker. This will be interesting because he and I have never discussed conjunctions. Usually, when Duncan is on, we talk about um, manned missions to space, to Mars or to the moon, because he famously made the movie In the Shadow of the Moon. He's interviewed all of the Apollo astronauts and has great ideas and influential ideas about manned missions. Now, this is something completely different, and we've not rehearsed this. So, we're talking about something that does not involve space travel. We're talking about looking into the sky, seeing two objects that are really not physically connected, they're just line of sight, lined up. And so, let me ask you, without having prepped this at all, do you like conjunctions? Are there any in the past that have stood out to you or influenced you?
No, definitely. I mean, they're beautiful, and it's funny. I remember when I was about 11 that there was a conjunction between Jupiter and Saturn, and that was in the winter of it must have been, I think it was about 81. And I remember because it was the first, when you're young and you start to get into astronomy and you start to learn where your planets are. I had this fantastic opportunity where the two of them, Jupiter and Saturn, these two sort of gaseous giants, appeared very close to each other in the sky. And there was something really magical about that. And I think conjunctions are just beautiful. They're just the most beautiful celestial sights that you can see because they remind you of what's out there. We're not the only planet. There's a whole suite of planets that are orbiting the sun. And now and again, you see them come together in these beautiful groupings, and sometimes they involve a moon, and sometimes you get three planets, can align. And I think they're a really beautiful spectacle, and they really help you remember that we it's not just Earth in this solar system. There are these other planetary bodies out there as well.
Yes, well said. And of course, sometimes they even align with distant stars. Astronomer Duncan has a doctorate. He's Doctor Kopp, doctorate in astronomy, so he knows that. But here's something interesting. Not all professional astronomers know the actual sky. So again, even though we haven't rehearsed this, if I were to say to you, which stars have you noticed planets being next to or aligning with? Which of the bright stars in the sky?
Oh well, there's always a favorite. Sometimes you get Mars come close to Aldebaran
Mhm.
in Taurus, the bull, and that's a red giant. And so they have very similar colours. And I've seen that before, and that's really rather beautiful when you get this particular star that's quite orangey, quite bright. It's a first magnitude star, and it's orange, and then you get Mars as well, and so Mars is the red world and has an orangey hue because of its surface color, and so seeing those two together is always quite nice, and I think any of the first magnitude stars that are in the zodiacal constellations, when you get planets come close to those first magnitude stars, that can be quite attractive as well.
Yes, yes, and there are some with contrasting colors. What other stars can the planets line up with? The
Oh
bright
well, I mean,
stars.
it's quite interesting. Sometimes, if you get something like a bright first magnitude hot star that's sort of blue or white, with something like Mars, then you get a really beautiful contrast. The other thing that's really beautiful sometimes is if you get some of the planets come close to some of the messier objects. For example, I think it's the Pleiades, which is also known as the Seven Sisters, M45. That's really spectacular because you've got these very young blue hot stars that are only about 60 million years old. Sounds old, but in fact it's not very old at all. And sometimes you get Jupiter or Saturn that wander quite close to that lovely young open star cluster, and that's beautiful. Again, it's just that lovely contrast of something that's very close to you, and this magnificent sort of wonderful backdrop that you get amongst the sort of stars out there that we can see. So it's always nice to see those groupings, I think.
Yes, yes, and I'm glad you said that because many professional astronomers really don't know the sky at all. So when you mention the Pleiades star cluster or blue stars that an orange planet can be near, Spica or Regulus, and you see those color contrasts, yes, I'm absolutely in total agreement. It just touches a chord. Now, the funny thing is, there is no real scientific discoveries available when we see a bright planet near one of these bright stars or a bright planet near another
Right.
bright planet, as we're getting last night and again tonight, Jupiter and Venus. You can't say, well, we're going to use the Keck telescope tonight because we're going to learn this or that. No, no, there's no science that can be squeezed out of it. And I like that because it means that here we go, astronomers going back to almost our roots, our origins, to the ancient Arabic star watchers, to the ancient Greeks, Ptolemy, and all the rest. Who I shouldn't mention Ptolemy because he set back science for 2,000 years. I should prefer to say Aristarchus or some of the ones who were truly ahead of their time. But yes, and the chord that it touches, the feeling that you get, the some of us, as you said, were inspired by conjunctions, by these gorgeous coming together of objects to get into astronomy in the first place, even if we later learned that there's no real no real science behind it, sort of like a lunar eclipse. What science can you do with a lunar eclipse? Little or none, as opposed to a total solar eclipse. But some of these things are just there for inspiration and for pleasure, aren't they? And that's what's happening
Totally.
tonight.
I really agree. I really agree with that thought, Bob. You're quite right, because some of these things, they're just purely aesthetic. They're just beautiful, and they're just there for us to look at. And how lucky we are just to ponder them and just look at them. And I think it just instills in you a sense of, we're not the only planet, or we're not alone. There's so much else that goes on out there, and in our daily lives we forget about these things. But once in a while we can look up and see something that catches our eye, and a couple of people have already texted me today saying, "Hey, what are those two bright stars?" Well, they're not stars; they're planets. Planets? What planets are they? So people are looking and thinking, "Wow, that's interesting. That's beautiful." So that's always good, I think, and that's how I got into astronomy. I mean, that was one of the things that got me interested.
Yes, and look at this. I don't know if you can see the screen as well. I hope our
Just saw a
producer
time
will rerun
lapse.
that. There it is, a previous meeting of Jupiter and Venus, as seen from our Canary Island Observatory. And look at the sped up view that
Beautiful.
Paul Cox, your fellow British citizen, has taken on a
That's
previous time that it
great.
happened. And lovely, right?
Oh, I love these time lapses. I think they're the most beautiful things. I mean, they're just fantastic, and you can take them nowadays with just a digital SLR camera. They're quite simple to put together, but it's beautiful.
And of course, I mean, we could get all sciency and talk about Venus or talk about Jupiter. Both of those could occupy, either of us for an hour probably. Why don't you pick one? I'll pick the other, and let's rattle off for our members some of the things that, that strike us about either planet. Choose one, and I'll pick the other, and tell us some things about one of those that if
You
you're
know
if
which
you're
one I'm going to
if your
choose.
Aunt Lucy came to you and she doesn't know any astronomy, and Aunt Lucy said, yeah, tell me some interesting things about X. Go ahead. What
Okay.
would you say?
Well, it's got to be Venus for me. I spent 4 years studying Venus, so I can't let the side down by not talking about Venus. I think the most interesting thing about Venus for me, and it's still a conundrum, it's still something we're trying to find out, is you have this body. It doesn't matter if you could go there. It doesn't matter where you set foot. You'd put your foot on something that's volcanic. I mean, volcanism on Venus is ubiquitous. It's everywhere. There's every type of lava flow, volcano that you could possibly imagine. But we can't find the smoking gun. We cannot find any active volcanism. Now, Venus is about the same size as the Earth. The Earth has abundant volcanism. In fact, it's what drives our plate tectonics. It's what keeps our planet ticking over because it's trying to lose heat, primordial heat that it collected when it was formed. Venus is the same size. It should be doing the same thing. And yet we've yet to discover definite volcanic activity. And I think that would be a breakthrough for that planet if we could do that.
Now, tell me this. As I understand, the surface of Venus remakes itself like almost suddenly and every so often, and then it's brand new. So there must be explosive
Well,
paroxysms
that's a
of
theory,
activity.
and it's quite an old theory. And there were two schools when I was studying Venus. One was the sort of catastrophic turnover model, which was every X million of years, the planet literally turned inside out and built itself a new crust. And then there was the other model, which was gradually it started to resurface itself. And the way that we try and test these theories is with impact craters, because if you know how many impact craters there are on a surface of a body, you can understand how old it is. Now, Venus doesn't have many impacts. It's only about 800 impact craters. So we know that it's a relatively young surface. The question is, did that surface form quickly, rapidly, as you mentioned, Bob, or does it form at the same rate that the impacts pockmark the surface? And that was a big debate when I was researching, and I fell on the side of it was a gradual event. It wasn't a catastrophic event.
Okay.
For
Well,
lots of
that's
different
what I
reasons.
get. This is what I get for giving the knowledge that I had when I went to school quite a bit before you did, and actually having the audacity to mention that to someone whose PhD thesis was on Venus itself. So I'm getting my comeuppance. So it's really thought
No,
now to be
it's great.
slower
I
than
mean,
that.
this was one of the big sort of hotly debated scientific topics, and I'm not sure it's actually been resolved. So it's a really pertinent question to ask. It's a good question.
All right, let me ask you this then. Obviously, Venus does not have, as you well know, a magnetosphere, which suggests it doesn't have a molten iron interior as we have. So if it's not hot enough to have a molten iron interior, I know it spins very slowly, once every 244 days or so, slowest spinning object in the known universe. So is it that slow spin that's keeping it from having a magnetosphere, or is it the lack of a liquid
I
iron
think
core?
that's got a lot to do with it. And it could be that if you want to set up a magnetic dynamo, you've got to have dynamism. You've got to have that spinning. If you don't have that spinning, your magnetosphere is going to be weak. And I think that's got a lot to do with it. And also remember, Venus spins retrograde. It actually goes backwards. So something very strange happened to Venus since it was formed, because all the other planets, bar I think it's Uranus, which sort of rolls like a barrel, spin in a certain way. Venus bucks that trend and actually has a retrograde rotation. So something cataclysmic happened in its past to change that rotation.
All right,
And
I have
maybe
another
that's got
question.
something to
Hey,
do.
folks, I'm having so much fun here. I'm with a Venus expert. So things that have like little itches that I've had about Venus for a long time, I have them satisfied here now with
They're
everyone
great questions,
watching.
Bob. They're great
So
questions
now,
because they're the
now,
questions that we all ask.
Okay, so we know that Venus has this very slow 244-day spin. It's tilted almost about 100 degrees, and we say it's retrograde. But could we also say it's spinning the right way, except the tilt is even different from what we think? But it's the right way spin. It's just been knocked so far over that we could just see it the other way by tilting our head, kind of.
So it's all down to perspective, really, isn't it? It's a
Yep.
planetary perspective. Yeah, you could do, but I think that rotation will play a part with regards to why it has such a weak magnetosphere, and it just could be we're only really starting to understand the dynamic processes within the Earth with regards to how it sets up its magnetosphere. If you look at a planet like Mars, Mars also has a very weak magnetosphere, but that's because we think it's volcanically dead. It's died a death, and so those volcanic processes or internal movement of molten material has slowed to such a degree on Mars that again it's lost its magnetic field. And these things, they may sound quite trivial, but in fact they're very, very important because the magnetic field helps protect our atmosphere, for example. Whereas on Mars, because it's lost its magnetic field, it's believed that its atmosphere has been winnowed away over billions of years by solar radiation. So these things are actually quite important to us. And of course, if we didn't have a magnetosphere, we wouldn't be able to have a magnetic compass. So things like this are actually quite important. If you were to land on Venus, you wouldn't really, a compass wouldn't really help you at all.
Sorry to
Well,
interrupt.
we'll
This has
remember
been
that the next time we go.
so
Did I hear a voice speaking there? I think this is this time to wrap this up, perhaps? Is that it?
I was just gonna say, yeah, it's been such an intriguing conversation to really learn so much more about these planets that we're seeing in conjunction. But yes, we have a little bit more further in the show that we have to do. So we have to say goodbye to Duncan. But thank you so much, Duncan, for coming on the show today and really giving us some greater detail about these two planets in the night sky. Thank you very much.
Thank you for having me. Good to talk to you
Yeah.
both. Take care.
The same, Duncan. Bye. Till next time.
Bye-bye.
And so as we move further on in this night of conjunctions, we actually have some other images. Well, I said earlier in the show that T2, our scope that usually images planets, these two planets are probably going to be too low in the sky for it. We actually just braved the limits of our horizon, and we have some imagery that's coming in from the T2 scopes that shows these planets in greater detail that we've been seeing before, and it shows sort of why this is our planetary scope. And so here we have Jupiter that's just coming in, and also we have Venus in what looks like not really a whole planet. Like, what's sort of going on there?
Yes, it's missing part of the planet. These are the Kevorkians, the evil race of extrasolar life forms that have been coming into the solar system and taking entire chunks out of planets. And they've gotten to Venus. Let's hope that they can't get any closer and get to us. Well, Venus shows phases like the moon, unlike Jupiter, because you've got to be lit up from behind in order to get a crescent, and you have to be lit up from the side to get a half phase. So that's what we're seeing currently with these. This is a lovely, and you only get this when Venus comes close to us. So this is a function of how Venus is just about at its brightest now. We've been waiting and waiting for it to reach its brightest. And for all of our members, listeners who are in the country, who don't live in the city, half the world lives in the cities these days. But if you're in the countryside, you can get out, wait a few days for the moon not to be out in the sky, so it's a dark night. Spread a sheet, a white surface. You need a white surface. You'll see your shadow by Venus light. That's how brilliant it is. So, on top of all these other great things that Duncan was telling us about, we never got to interesting things about Jupiter because we were just so fascinated by Venus by itself. We could have kept going. That was his field of expertise back in school. But look at this. Isn't this gorgeous? No detail because we're only looking at cloud tops. It's an overcast, featureless, but moon-like in its phases, and you can even see a faint glow often on the dark side a, of Venus. In the case of our moon, that's the part of the moon that's being lit up by the Earth. In the case of Venus, we have a just an interesting glow that does not have that, but is caused by diffusion through the clouds. Lovely.
And I think this is such a particularly cool view as we see both the live view from our T2 planetary imaging scope as well as from the T1 scope. It's a little bit more powerful. And so we see Venus in the top box there in the bottom right corner. That's that big sort of bright object. And then we see it with an actual phase here. So we see the differences in terms of what you can do with different telescopes. And so we can also see that with Jupiter as well, just bringing that in as contrast. We see it here. We actually see bands. We see detail. And so if you're
Yes.
somebody that really likes imaging planets in the clubhouse, this is we have the scope for you, and we also have a Jupiter watch group because Jupiter will not be up for too much longer. We're going to be imaging it as long as we can, and so join in on that fun if Jupiter is your planet, is your thing. But
With the
there's
knowledge, of course, that the time for Jupiter was really 4 and 5 months ago, because it's on the far side of the sun, we have to look through lots of air. It's low in the sky, and anytime we do that, it's going to be blurry, just because we're looking through approximately 8 times more air than we did when we at SLU were imaging Jupiter just 4 months ago. So this is not an optimal time to see detail, but it's always a great time just to see it, period. Plus, Jupiter's pretty darn far away now. It varies in size from about 50 arc seconds to 30 arc seconds, and it's approaching that lower limit now. Whereas Venus is doing just the opposite because it's getting closer and closer. It's approaching, it almost reaches a full arc minute. It gets to 58 or so arc seconds at its closest. And so that's why using the same magnification, Eric was just talking about the views through our high magnification telescope, and they were the same power looking at Jupiter and Venus, and the two were not that different in apparent size, the two disks, even though, as we mentioned earlier, Jupiter is actually much, much larger as a planet. See, here's the apparent size using the same power, same magnification, and you can see how large it seems, but it's way off in the distance. 13 times or so bigger than Venus. Now we'll look at Venus, which is even a little bit smaller than Earth, a much smaller body than Jupiter, but look at its apparent size with the same magnification. See, not very different. A little bit larger. Venus looks a little larger. That's because Venus is approaching the largest it gets. Not there yet, but it's approaching it, whereas Jupiter is very nearly at the smallest apparent size because it's so far in the distance. So fascinating with the higher power telescopes, fascinating that little cutout view you're seeing in the upper left where you're seeing them both in the same field of view, and fascinating also for you to see yourselves when you step out. If you miss it tonight, or if it's cloudy, or if it's already after sunset for you, it won't be. You'll see it if it's clear. Just go out about 40 minutes after sunset. But watch it tomorrow night and the night after, and you'll see the gap widening as Venus has now passed Jupiter, and you'll see the change in their apparent separation 100% due to Venus's super fast 22 mile per second orbital motion. You can essentially regard Jupiter as being stationary in the background because it's so far away. And the change from night to night, you're actually watching Venus circling around the sun. It's orbital motion. It's so cool.
really, and I mean, you really said it, Bob, in that seeing these different perspectives, seeing it from these different scopes, seeing it with your own eyes out in a field out away from any city lights. There's a lot of ways to really experience this conjunction in a powerful and personal way. And it's do what you can. We're happy that you came to SLU and you saw the conjunction here because we're happy to provide you with that perspective. And so as we're sort of going in toward the end of our conjunction show, and we had a lot of sort of profound thoughts about what conjunctions can mean to us and what they really are in the night sky. But as we get to the last of the any sort of final thoughts on what conjunctions mean to you, Bob?
Well, yeah, I would say if any of our viewers and members have enjoyed this, have sort of come down with conjunctionitis after this, well, there's more where this came from because the planets are in the same flat plane. And once or sometimes several times a year, they meet in various configurations. So it's one of the fun things we do. This was the brightest conjunction of the year, but there'll be other ones. So stick around where the universe is not finished with us, and we at SLU are certainly not finished with the universe.
Absolutely. We'll be covering the conjunctions as they come. And yeah, speaking of upcoming shows, we have quite a few coming up the next week that are a little intriguing. I mentioned earlier in the show that we're going to be covering Tanabata on the 7th of this month, looking at the stars Vega and Altair and the path that they might take to meet in the middle. It'll be a very fun show full of both astronomy about unique NGC objects in between them, as well as the culture sort of surrounding this story that we relate to the night sky. And of course, a couple days later, we can't forget, particularly for Clubhouse members, a really new and exciting show. It's going to be on the 9th. We're going to be having a call-in show where we'd love to take your calls live on the air. If you have a Skype and an internet connection, we can connect with you. And what our subject for this call-in show is going to be is it's going to be about comets. So if comets are something that you're particularly passionate about, that you'd like to talk with an expert, SLU astronomer Will Gator, about on the air, you can ask him questions. We can, talk about your favorite comets. We're going to be showing live comets during that conversation. So if this sounds like something you'd be intrigued by, let us know. You can email me at eric@slu.com, and I would love to see if there's any of you that'd really be interested to call in later on next week, because we'd love to have a conversation with you, Clubhouse members, live on the air. So yes, there are lots of shows coming up, and we've just finished a very cool one where we saw two planets as they were dancing about the night sky. And so we hope you very much enjoyed. We thank you for watching, and we hope to see you again. But for now, this has been Eric and Bob for SLU. And it's summer here in the Canary Islands, where about 95% of the days it is sunny. It's why we have one of our observatories over there, and just one of the greatest sights to observe in the world. And it's going to be great to be bringing you some beautiful live imagery that's going to be coming in just now of this exciting conjunction. And with me today to walk you through all of what's going on here, we have SLU astronomer Bob Berman, who's going to be giving us the ins and outs of conjunctions, and this conjunction in particular. So welcome to the show, Bob, and thank you very much for joining me tonight.
It's absolutely a pleasure. You're in a good mood, aren't you, Eric?
Oh, yeah,
I think the conjunction
I'm
is
always
bringing
in a
out
good
the
mood.
best in us.
This is a fun, really fun sort of event to celebrate, in particular just because there's so much going on. And we actually have been doing some intriguing things with the SLU scopes tonight to make sure that we're going to be getting that live imagery to you, where we're actually this group of stars, or this group of planets, Venus and Jupiter, are actually so low in the sky and the horizon of the Canary Islands right now that we can't actually show them with our T2, our planetary imaging scope. And so what we're doing is we're using our higher powered T1 scope to image these objects, and our observatory engineer, Paul Cox, is having to customize this imagery, the visualizations of this imagery, to make sure that we're getting it. And it's been quite an adventure. We're using what's called an H-alpha filter with only 2-second exposures. Like, can you sort of contextualize that for us, Bob? Like, what does that mean in terms of imaging something?
Oh, that's very cool. That's very unusual. And he's the wizard. Show, if you're in a place that has clear skies, maybe you are, maybe you're not, but if you are, and it's around sunset, wait till about half an hour or 45 minutes after sunset, look in the direction of the setting sun, where the sun did set, and you can't miss it. There they are, the two brightest objects in the night sky, other than the moon. And brightest one is Venus, and the other one is Jupiter. So you don't need star maps, or you don't need your personal astronomer around. We're here to celebrate it and to look at the lore and legend and mythology and science behind this, because conjunctions have always been celebrated throughout history. You know, the Mayans would throw their least favorite in laws from pyramids down on the Yucatan Peninsula, and other parts of what are now Guatemala and southern Mexico. Uh, and other cultures did too, to celebrate bright conjunctions. This is the brightest of the year. This is really the best. And so when we look at it, we take different views, close up views, and we had it just before we went on the show, them in the same field of view. So I know, although it's tricky, we're going to do it again. But again, to our listeners, head outside. If it's clear and if it's the right time, there'll only be about a half an hour window where it's optimal. That is, when they haven't gotten too low, and yet the sky has gotten dark enough behind it to show it optimally. And that happens about 40 or 45 minutes after sunset. For most parts of the United States, that's around 9:15-ish or so, or 9:30, depending upon how far you are from your local.
This live SLU show is brought to you by the support of SLU members and the following sponsors. Visit SLU.com to become a member today.
Hi, and welcome to our latest live SLU show. I'm Eric Edelman, broadcasting to you live from Smoky Hollow Studios in SLU HQ in Washington Depot, Connecticut. And today we're going to be traveling across the ocean and going to the Canary Islands, 9,000 feet above sea level. And we're going to be checking out a beautiful, beautiful conjunction of the planets Venus and Jupiter. And it's great to see this perfectly clear sky in the Canary Islands.
He's the one who's behind the scenes, you know, he's doing all these things that nobody's even watching. And that's why he allows the telescope to override its normal limits, you know, how low it can see. He's the guy. And we've been waiting for this conjunction for months. Venus has been brilliant ever since it emerged from behind the sun's glare and has been getting more and more prominent, still brightening up. It's just about at its brightest now. And at the same time, there is Jupiter moving slowly, as it always does, because it takes 11.86 years, almost 12 years to go around the sun. So it's been sitting there in the constellation of Cancer, the crab, not too far from Leo. And Venus moving fast because it moves at 22 miles per second, 40 times faster than a high velocity rifle bullet, heading toward Jupiter night after night after night. And this is the series of days. Last night, tonight, this is when they're closest. And we got them.
We do indeed. And really, without any further ado, here is a live imagery coming in from T1 just to show you here. This what we see as this bright blooming object. This is Venus, and just a little bit above the screen, just a little out of the screen, is Jupiter. And what we're going to be working on right now throughout this show is to try and get those in the same frame. It's going to be a close call, and we're going to try our best to do it. But we're going to see these planets throughout the night as we struggle to see them both together. And that is Venus.
Yes. And you don't have to struggle. I'm talking to our members who are watching this